So this is like the old school long division that you did back in, I don't know, elementary, maybe middle school. So where you do the division sign, the first thing goes underneath. We are learning both long division and synthetic division because you do have to know long division for calculus. And then what goes on the outside is the 2x plus 1. So when you are doing this, what you're trying to figure out is you're just looking, by the way, at the first terms only. So you're trying to figure out what times 2x will give me 2x cubed. It's going to be x squared. So I write x squared up here. And then I'm going to multiply x squared times 2x plus 1. You might be able to do some of this in your head, and that's fine, but be very, very careful. It's easy to make mistakes on this one. So when I do x squared times 2x plus 1, I get 2x cubed plus x squared. When I go write it underneath, I am going to change the signs. So I'm going to make this negative 2x cubed minus x squared because you're subtracting that. Okay? What happens is, what should always happen is the first term cancels, and then you add down. So 11 minus 1, so this is 10x squared, and then bring the rest of it down, plus 9x plus 2. Now you'll do the next one. 2x times what gives me 10x squared? 5x. So plus 5x, and then I do 5x times 2x plus 1. And then whenever I write it underneath, I do what with the signs? I change all the signs. So negative 10x squared minus 5x. And I get 4x plus 2. And then the last one I get, what times 2x gives me 4x? It's going to be a plus 2. And then 2 times 2x plus 1 is 4x plus 2. Change the signs, negative 4x minus 2. I get 0. What does it mean when you have a remainder of 0? It's no remainder. What does that mean? So think of it in terms of numbers. If I do 40 divided by 5, I get a remainder of what? 0, because why? 5 is a factor of 40. So when you get a remainder of 0, that indicates that what you were dividing by is a factor. So if I did 100 divided by 9, do I get a remainder of 0? No, because 9's not a factor of 100. Okay? So you need to remember that concept because that is used when we're doing long and synthetic division. Okay, so this is exactly the same thing as the previous one, just written a different way. Writing it as a fraction is the same thing as asking to do the top divided by the bottom. And then also, whenever you have a missing term, so for example, we're missing the x squared term, you use it with a coefficient of 0 as a placeholder. So that's 5x to the 4th plus 2x cubed plus 0x squared minus 9x plus 12 divided by x squared minus 3x plus 4. So again, what times x squared is going to give me 5x to the 4th? 5x to the 3rd. Squared? Oh, sorry, squared, yes. 5x squared. And so I have now 5x squared times x squared minus 3x plus 4. And then whenever I rewrite it, I make sure that I switch all the signs. So that's going to be negative 5x to the 4th plus 15x cubed minus 20x squared. And then I'm going to do the next one. So what times x squared gives me 17x cubed? And that's going to be 17x. And then when I write this, this becomes negative 17x cubed plus 51x squared. Oh, that should be x squared and an x. Minus 68x. So we have 31x squared minus 77x plus 12. And then the last one, what times x squared gives me 31x squared, and that's going to be 31. So I get 31x squared minus 93x plus 124. So negative 31x squared plus 93x minus 124. And that gives me a remainder of 16x minus 112. So, whenever we have a remainder, the way that you write that, there's your answer. So we have 5x squared plus 17x plus 31 plus, and then whatever you have left over, 16x minus 112 over what you divided by. The reason that we have to learn how to do long division and not just use synthetic division is that synthetic division does not work with number 2. You have to have a linear factor, so you can't have anything higher than an x in order for synthetic to work. So that's why we have to learn long division, because you have to understand how to do that in calculus if you're dividing by something other than a linear term. All right, so synthetic division. This is the one that we prefer to do. It's much easier, much quicker. So you, again, have to be dividing by a linear factor, so x can't be higher than an x to the first. In order to determine what you're dividing by, set this equal to 0 and solve for x. So we put negative 2 in the box, and then we write the coefficients of everything. Don't forget on number 3, just like number 2, we are missing an x squared term. So you have to use 0 as a placeholder. So that's going to be 5, 0, 6, 8. You always bring down the first term, and then you do what's in the box, negative 2 times 5, which is negative 10, and put that under the 0. And then make sure you add down. So negative 10. Multiply, 20, add down, 26. Multiply, negative 52. Add down, we get negative 44. Now, my answer for this, I started off with an x cubed, so my answer is going to start off with x squared. So x squared, x, and then nothing. So this is 5x squared minus 10x plus 26, and then my remainder is going to be plus the remainder over what I divided by. So go do number 4 on your own, and then I will write the answer up here. Don't forget, check for missing terms. Yep, I messed up a lot there. Negative 2. Okay, so obviously, you notice I made a mistake on number 4. It'd be really nice if there was a way to be able to check to see if you did it right. Guess what? There is. It doesn't give you the answer. It just allows you to check to see if you got it correct, because if it works out, the chances of you having messed something up is very, very slim. So that's what we're about to talk about. Okay, so number 5. So first what we're going to do on number 5 is we're going to go ahead and do synthetic division. Now, because this already gives me x equals, I don't need to do anything extra. I use that number. If it had given me a factor like x plus 2, then I get it equal to 0 and solve. It already gives me the number. So plug that in. Synthetic division, I have 3, 8, 5, negative 7. All right, bring down the 3. We have negative 6. Add down. And we get negative 9 as my remainder. Now, what this is actually asking us to do, I had you do this for a reason because I wanted you to see this connection. What number 5 is actually asking us to do is just, they wanted to only know what the remainder was. Well, I can do that with synthetic division, or I can find f of negative 2, and that will tell me what my remainder is supposed to be. So when I plug in negative 2 for x, and by the way, you'd be allowed to use a calculator for this, so you don't have to have this done without a calculator. If I had done this correctly, I will get negative 9 as my answer. So what the connection is that if you plug in the number that you used when you did synthetic division, if you plug that into the original problem, it will tell you what your remainder is supposed to be. So it's also a nice way to check, because if you get the same remainder both ways, chances are you did the synthetic division correctly. It's going to be really hard for you to mess up synthetic division and still get the same remainder.
So you can just plug it in.
This only will work if all I want to know is the remainder. So it's useful for 2 ways. One, I mean, it's a concept that they're probably going to ask you on the dual credit final, okay? But it's a nice way to check yourself on synthetic division, because you can plug that in to see, did I do my synthetic division correctly? Which is what I do most of the time. I always do it because I usually go through synthetic division so quickly that I make mistakes sometimes. So I'm able to catch myself. So then number 6, go ahead and find out, just on number 6, to only find out what the remainder is. So all I'm going to do is I'm going to find g of negative 1. So 4 times negative 1 cubed plus 10 times negative 1 squared minus 3 times negative 1 minus 8. If I did my math correct, we get negative 1. Positive 1. Thank you. Okay, so the factor theorem states that it's a factor only if the remainder is 0. That should make sense to you, just like we talked about. 9 is not a factor of 100 because the remainder is not 0. 9 is a factor of 90 because the remainder is 0. So it's the same with polynomials. If your remainder isn't 0, it's not a factor. If the remainder is 0, then f of x is, it's a factor, and if it's 0, k comma 0 is an x-intercept. So remember, it being a factor means that tells you how to solve for a 0 or an x-intercept by just plugging that, setting that equal to 0 and solving. So that's just doing what we've been doing, like when we had to factor and solve. Each factor set equal to 0 gives you your x-intercepts or your zeros. So that's the same thing here with polynomials. So number 7. Show that x minus 2 and x plus 3 are factors. First of all, what would I do to show that? I show that their remainder is 0, either using synthetic division or using the remainder theorem. Now, here's the deal. You have to do synthetic division anyways on this because it also wants us to find the remaining factors. So we're going to have to divide out using synthetic division. So it helps. If I hadn't asked you to do that second part and I just asked you to show that they're factors, you can use the remainder theorem. For this one, we're going to go ahead and do synthetic. So first, I'm going to use x equals 2. Now, because I'm saying that they're zeros, what should my remainder be? 0. So if you don't get 0, you did something wrong. So I got 0 as my remainder. I know that I did that first part correctly. Now what I'm going to do is I'm going to check x plus 3. Here's where you have to be careful. Do not use the original function. Use the answer that you just got. So we ignore the remainder, and now we use -3 and do synthetic division with that part.
So why would we use the original?
We don't use the original one because we're trying to divide it out and simplify it down. We're trying to break it down into something that we can now find zeros with. So when we divide each time out, what we're doing is we're basically doing the shorthand version of long division. Now what happens is I started off with an x to the 4th. If I divided, what we call that is depressing the polynomial. If I depress it twice, I decrease the exponent by 2, which means now I'm starting off with an x squared. So this is 2x squared plus 5x plus 3. You know how to solve a quadratic like 5 different ways. You can solve it by factoring. You can solve it by square roots, or not square roots, completing the square. You can solve it by quadratic formula. You can solve it by, I think there's 1 or 2 other methods we may have used. So you've got multiple ways to solve a quadratic that you're supposed to know how to do. So now we do that. By the way, is this one factorable? This one is not factorable, I don't believe. So I believe we're going to have to use quadratic formula. Okay, so it's factorable. If I had done quadratic formula, I would still get the same answers. It doesn't matter. But yes, 2x plus 3, x plus 1. So I get x equals -3 halves and x equals -1. So I found the remaining factors, and then I listed all of the zeros. So what are my other zeros other than -3 halves and 1? We also have x equals 2 and x equals -3 from the factors that were given at the beginning. Okay, so we're going to use 7 halves. If you want to put it as 3.5, doesn't matter. It's the same thing. 2, -15, 34, -21. So we bring down the 2. 2 times 7 halves is 7. Add down, get -8. 7 halves times -8, -56 over 2, which is negative what? 28. Add down, we get 6. 42 over 2, 21, which should happen because we want our remainder to be 0. Again, if it's a non-calculator, you get a baby calculator. You can do 3.5 times all these and not have a problem with it, okay? They all came out nice. So I started off with a cube, and now I'm going to start off with an x squared. So this is 2x squared minus 8x plus 6 equals 0. What is the first step in factoring? Greatest common factor. And guess what? Once I factor out the GCF, hopefully you're going to notice, oh, that's an easy factoring right there. X minus 3, x minus 1. So I've got my other remaining factors. And then my zeros are x equals 7 halves, x equals 3, and x equals 1.